Okay, so 1A, continuing with that. Number 5. So let's go to number 5. Coal reacts with oxygen. So we write your coal reacts with oxygen a little bit below the plus. Remember, this coal is more than 90% carbon. So coal and carbon are same. So we write the symbol for carbon. Mentioned as solid, react with oxygen. O2 in the gaseous form. Then we get carbon dioxide. And the word equation is mentioned as gaseous, so small g at the back. So this is the skeletal equation. Let's balance it. One carbon atom, no carbon here. One carbon atom on the left side, and on the right side of arrow, one carbon. So balance so far. Two oxygen atoms, two oxygen atoms. So this is a skeletal equation, an example of a skeletal equation which is already balanced, and we need not do anything to balance further. Some skeletal equations are like that. Okay, most of the skeletal equation needs to be balanced, but some are already balanced when we convert it to the skeletal form without any more further balancing. It will appear as balanced. 6. Hydrogen and oxygen give water. Okay, so hydrogen and oxygen burn. So H2 in the gaseous form, O2 in the gaseous form. Word equation is saying gaseous, so we write G to give water. So this is how, in passing current, we can get this water liquid. So this is how we can manufacture water by electrolysis, by passing electric current. Two hydrogen atom on the left side, two hydrogen atom on the right side. Two oxygen atom on the left side, but only one oxygen atom on the right side. As I said, how many atom is there should be looked from the back and not from the left. Left 1, 2 belongs to H, not to O. So to make it 2O on the right side also, we have to balance right in front, slightly bigger than the subscript. So 2 1s are 2O or 2. But the moment we do that, hydrogen has increased on the right side. So 2 2s are 4 hydrogen atoms. So here also, 2 2s are 4 hydrogen atoms. Now the equation is balanced. We know at the back 2 means it's a molecule. More than 1 is molecule. 2 is a molecule. 2 plus 1, 3, so molecule. Everything is a molecule. Let us read the balanced equation. 2 molecules of hydrogen react with 1 molecule of oxygen to give us 2 molecules of water. Okay, so number 7. Just keep it simple and listen carefully. It's not hard, okay? Balancing chemical equation. Okay, so here, let's go to the next one. Calcium oxide react with water to give calcium hydroxide in aqueous form. Calcium oxide mentioned as solid, put in water, which is a liquid. Everybody of us know calcium ion Ca2 plus, oxide ion O2 minus, so 2 valency cancel. We are recalling the starter to write the formula, right, to give us calcium hydroxide in the aqueous form, CaOH, calcium ion Ca2 plus, hydroxide ion OH1 minus, so 1 and 2 can cancel. So when you not shift this 1, but when we bring this 2 to the lower backside of OH, we need to put a bracket because hydroxide is a compound ion, hydroxide ion is a compound ion because it contains more than 1 atom, that is 1 plus 1, 1 oxygen atom, 1 hydrogen atom makes hydroxide ion, OH1 minus C, 2 atoms. So any ion having more than 1 atom is called a compound ion, and if it's a compound ion and the valency you're bringing down, as in this case, is greater than 1, which is 2 or 3 like that, we need to put a bracket, otherwise it's wrong. If it's a simple ion, we should not put a bracket, even if the valency is higher than 1. Okay, so keep that in mind, the rule of writing chemical formula. So this is in the aqueous form, and in the process, a lot of heat is released. So if you put this calcium oxide, which is tuna used for making panna, in a bucket, and then you pour water inside, it will react. And after 2-3 minutes, you dip your finger inside. It will be quite hot because heat is released. And the clear liquid that is left behind after reaction is the calcium hydroxide in the aqueous form, means dissolved form. So this is the reaction. Now let us balance, check for balancing. Calcium, please look at this one, Ca means calcium atom, C means carbon. They are not same. C and Ca are not same. C of the Ca and C here is not same. C means carbon atom. As I said, C capital small a, capital C small a, calcium atom. So one calcium atom on the left, because there is no calcium atom here. On the right, one calcium atom, because there's no more calcium atom anywhere else. Then 1 plus 1, 2 oxygen atom on the left side. And bracket means this 2 belongs to both of these atoms. So 2 ones are 2 oxygen atom on the right side, balanced. H2. So 2 on hydrogen atom on the left side. 2 ones are 2 hydrogen atoms on the right side. So this is another skeletal equation similar to this, which is already balanced without us trying to balance it anymore. Okay, so that's a skeletal equation which is already balanced. Let's read. 1 plus 1 means 2, so molecule. 2 plus 1 is 3 molecule. 1 plus 2, 4 or 3. Then another 2 ones are 2, so 2, 2, 4. 5 atoms makes calcium hydroxide. Definitely molecule. So molecule, molecule, molecule. Let's read the equation. 1 atom, sorry, 1 molecule, yes, 1 plus 1, 2. 1 molecule of calcium oxide reacts with 1 molecule of water to give us 1 molecule of calcium hydroxide in the aqueous form. That's how we read it. Okay, 3 more to go, 8. Let's write here 8. Since you're getting more comfortable, I think we can just go smoothly without being too slow. Calcium hydroxide react with carbon dioxide. Calcium, so right here, and write your hydroxide below, because you will be needing a lot of space on the right side, so that your equation can appear in a single line, because if it appears in single line, it's easier to balance. Otherwise, for lack of space, you'll have to write some products here in 2 rows, and it's difficult to observe, right? C and balance. So calcium hydroxide in the aqueous form Ca2 plus OH1 minus, so 2 down here with a bracket, as I said, explanation here in the aqueous form. The word equation is saying react with carbon dioxide. So here we write carbon dioxide. I hope you're getting right. So here carbon dioxide, so CO2 in the gaseous form. Over a period of time, okay, we get here calcium carbonate, which is a whitish solid calcium, whitish and shiny as well. So we write the formula Ca2 plus carbonate ion. We can recall the starter. CO3 2 minus, so valency 2 minus 2 plus cancel, so 1 1 need not be shifted. Whitish solid in the solid form, and we get water. And in the water here, I can write water. This will go as steam into the atmosphere. So this is the equation. Let us try to balance it. Ca, calcium atom 1 on the left side, 1 on the right side. 2 ones are 2O plus 2O, 4 oxygen atoms on the left side. 3 plus 1 oxygen atoms on the right side. We finish O. Let's go to H. 2 ones are 2H, no H here. Here also 2 hydrogen atoms, so balanced. So next is C. As we said, Ca here is calcium atom, C here is carbon atom. So 1 carbon atom on the left side, 1 carbon atom on the right side, right? So balance. O we have already balanced earlier. So this is another skeletal equation which is already balanced on its own. We don't need to further balance it. So let's read. 2 hydrogen atom, 2 oxygen, so 4 atoms plus 1 calcium. 5 atoms make calcium hydroxide, so molecule. 1 plus 2, 3 atoms, so molecule. 1 plus 1, 2 plus 3, 5 atoms, so molecule. 2 plus 1, 3 atoms, so molecule. Everything is molecule here. Right, it's important to identify which is an atom and a molecule. That will enable us to read the equation clearly, right? So 1 molecule of calcium hydroxide react with 1 molecule of carbon dioxide to give us 1 molecule of calcium carbonate and 1 molecule of water. Okay, so here, go to the next one, 9th. 2 more. We're done with this Test-1A. So 9 is methane. Methane is a gas. It's an organic compound. Just memorize the formula CH4G. Burns in or reacts with oxygen, O2, which is in the gaseous form, to give us carbon dioxide. In the word equation, carbon dioxide is mentioned as gas, I think. Yes, and steam. So steam means chemically is the same as water. So H2O in the back, G, steam, the gaseous form of water. Let's try to balance it. One carbon atom on the left side, no carbon here, so one, no carbon there, so one, balance so far. 4 hydrogen atom on the left side, no hydrogen here. So to make it 4, let's put here 2 bigger than this subscript. 2 to are 4 hydrogen atoms on the right side. So hydrogen also balanced. So let's go to next. 2 oxygen atoms on the left side. 2 plus 2 1s are. This 2 belongs to H, okay? This is the back one. 2 1 2s are 2 plus 2, 4 oxygen atoms on the right side. So to make it 4, there is no way, but 2 2s are slightly bigger than this subscript. Because this is the main script, bigger script. Main script means bigger number, bigger size. So 2 oxygen atoms on the left side. 4 plus 1, 5 atoms, so molecule. Don't look at the front. 2, so more than 1, so molecule. 2 plus 1, 3, so molecule. 2 plus 1, 3, so molecule. Everything is a molecule. Now let us read the balance equation. 1 molecule of methane burns in 2 molecules of oxygen or reacts with 2 molecules of oxygen. You can also read it like that, to give us 1 molecule of carbon dioxide and 2 molecules of steam are released. Okay, so last one. So the last question is glucose. This is respiration. So number 10. Glucose in the aqueous form reacts with oxygen in our stomach, because this is nothing but respiration. We take food into our body through our stomach, and in our stomach this chemical reaction called respiration takes place to give us energy in our body. Okay, energy means heat in the aqueous form. So glucose C6H12O6 in the aqueous form in our stomach react with oxygen in the aqueous form to give us 6 carbon dioxide. Carbon dioxide is released in the process of respiration. That's how when we take in oxygen, respiration takes place, and after respiration, as we breathe out, that carbon dioxide is coming out, right? So here, carbon dioxide, CO2 in the gaseous form is released from our body, and water. So water in the liquid form is released in our body. Okay, and then a lot of energy is released for our body to function. We need energy to function, right? So here, this also slightly memorize and go. 2 reactants are there, glucose and oxygen. 2 products. So let's just memorize the left. Go to the example knowing that 1 molecule of glucose reacts with 6 molecules of oxygen on the left side in respiration. Just memorize 1 and 6. And know that this number need not be changed anymore, it's correct. Use that to balance the right side, like we did for photosynthesis. Okay, some equations, if you do that, it makes it a lot easier. Most of it, we don't have to do any memorization. Okay, we can do it directly by trial and error method. 6 carbon atoms on the right, also only one place, no here. So only way to make it 6 is put 6 there, right in front of the C, because we are not allowed to balance from the back. Then let's go to next. H here 1, here no, ones only, here also ones. This time it's okay, we can use H12, balance next H. 12 hydrogen atom, we know this is surely balanced. No change is needed, so right side should also be 12. Only one place, very easy, 6 2s are 12. And let's go to O. So that's better balance H, because H appears only once, both left and right. But oxygen appears twice here, there also twice. It's more difficult to balance oxygen. So let's always remember to balance the hydrogen ahead of oxygen. Always try to balance the atom which occurs lesser number of times first, or ahead of the atoms which occur more times, both on right and left side. So O is 6, 6 1s are 6, and then 6 2s are 12, 18 O. 12 plus 6, 18. Right side, 6 2s are 12, plus 6 1s are 6, 18 O. So this is quite easy, because the moment we balance hydrogen on in the equation, oxygen automatically gets balanced. So now we can read the equation finally. 1 molecule of glucose in respiration in our body reacts with 6 molecules of oxygen to give us 6 molecules of carbon dioxide and 6 molecules of water, along with the release of a lot of energy in our body, right? This is called respiration. This chemical reaction occurring in our body is called respiration. So as I said, in balancing chemical equation, write the skeletal equation from the word equation. That means change the word equation written in English into the symbolic form. Then you check and make sure each type of atom are equal on both left. The number of atoms of each type on the left are equal to the number of the same type of atoms on the right. And that is called a balanced chemical equation. And this test is saying, write from the following word equations, form or write balanced chemical equations. So this is how we do. Okay, so this is the end of the test 1A.